Thank you very much for having me, and thank you everyone for joining in from their homes. Today, I want to talk to you about reversing Android applications. My goal for me for today is that you go home or leave the talk with the idea of how much information can actually be taken out of an APK that you put into the App Store. Okay, that you know what can someone that is not an engineer in your organization, what can they actually take out of the APK. I will be also talking a bit about some of the things that you can do to prevent these kind of things, but I will not go really dive into these protection measures because that's not kind of the scope of the talk. It's more like what would an attacker do when trying to look at your application. Okay, so a few words about me. My name is Marc. I'm joining from Barcelona. And I'm currently the tech lead at Build 38, where we develop some solutions for securing mobile applications, solutions for securing Android and iOS apps. Here you have my contact details. I will be sharing the slides of the talk afterwards. And if you have any question, you can find me on social networks as well. Okay. So let's get started. And first thing you might be asking yourselves is what the hell is reversing? So according to Wikipedia, when we are doing reverse engineering or back engineering, what we are trying to do is we are trying to get some information about a man-made thing without knowing details about its internal designs or architecture. So when we talk about software or Android apps, what we are trying to do is getting information about this piece of software without actually having access to source code, to architecture, to design specifications, and so on and so forth. But there is a catch that it's quite important to bear in mind, which is that in the EU, that's something which can get you into trouble. Actually, you could get fined if you reverse engineer someone else's application and they discover that you did so. They could actually sue you. That's different than in other places. For example, in the United States, there's if you behave in a certain way, like you give them a period notice before you go public with what you found, and you behave in goodwill, let's say, then you are covered by the law. But that's not the case in the EU. So this is something which is important to bear in mind. And this is why today I'm going to be using an application that I developed myself some years ago, which is, and here's where the beer comes in, which is basically an application for a beer festival that we organize with our friends in my hometown. My hometown is in Mallorca, and for 6 years now, 6 years, we've been organizing a craft beer festival, and we wanted to have an app, and I developed. So I'm going to using this application because it would have been, I could have developed a dummy application for the sake of this talk, but I think it's more interesting if we just use a real world application. Since this is mine, I'm not going to get into trouble because I'm not going to sue myself. Okay, I didn't develop alone. Giuseppe helped me in the iOS front, and Albert designed all the UI that is going to be seen, so great for them as well. And a bit of promo, if you will allow me. My hometown is in Mallorca, and we normally do the festival at the end, the first or second weekend of June. As a matter of fact, it was supposed to start tomorrow this year, but because of COVID, it's very likely that it's not going to happen. So yeah, if you happen to be in Mallorca next year around June, make sure to check it out. But yeah, enough promo. Let's get into the actual stuff. And the first thing you may be asking yourselves is where the fuck did I get started? Okay, where do I start to reverse engineering application? Well, the first thing, it may seem obvious, but not everybody remembers this step, is to know what the application is doing. So let me show you a few screenshots about the application that we are going to be reversing, just for the sake of being in the same page. It's an app for a beer festival, so it's have some basic functionalities like an agenda for the activities of the weekend, where we can there are certain events that require sign up, and sign up can be done also through the application. We normally bring around 100 types of beer, and they are all listed in the application. And finally, we have not all beers are available at the same time, but we have just normally 10 to 12 taps, and there is a live section where the 12 beers that are on tap can be checked out. Okay, that's basically this about the application. It's nothing too fancy. It's a simple app, but it serves its purpose for what we are trying to do here today. Okay, so let's get started about the reverse engineering. The first type of reverse engineering, or the first thing that we do when we reverse engineering, is normally static analysis. Static analysis, what we do is we are actually looking at the application, the decompiled application, without actually running it. So we are going to download the application, decompile it, and browse through whatever we get in our workstation. But the application is still it's not running, and hence it's called static. So the first thing we need to do is we need to get the APK. That's not difficult. There are tons of mirrors. You just put the name of the app on Google plus APK download, and you can download it. And then we need to decompile the application. And for this, we will use APK tool. Not sure if you noticed, but it's an open source tool. You have the link here. And if you are using Mac, just brew install APK tool, and you are good to go. And that's it. That's all we need to reverse engineer to decompile an Android application. Okay. So we open a terminal, and we use APK tool D, where D stands for decompile. And then we put the path to the APK that we just downloaded. And this is going to create a directory in wherever we run this command. And inside this directory, we are going to have the outputs of the decompilation. Okay, there are a few things here to see, but mainly what is relevant, or what we are going to be seeing today, is the manifest, the resources, and the Smiley. Let me explain what Smiley is later on. First thing we see is we can check is the manifest. The manifest can be recovered completely. There is like the same that you put in the Android Studio is going to be recovered by APK tool. So you can see all the permissions, all the activities, all the services, content receivers, anything that you put in the manifest is recovered by APK tool. And of course, this is probably not a problem from the security perspective, but for someone that is doing static analysis, it's a good hint about where are the main entry points of the application. So that's why the manifest is relevant, because it guides you to where to the point where you want to get started. Okay. Next thing we want to check out is the resources directory. For example, the layout directory. There's a bunch of things that we didn't put in there. It's actually put by the build system when building the application. So it's a merge of Android resources, our resources, and other the third-party libraries that we have integrated. But if you take a closer look, we see that our layouts are also there, for example. So this means that, and they are also not modified, which means that, of course, if someone decompiles your application, they can take your layout XMLs, and if someone wants to copy, for example, your UI, just doing this is very easy to do as well. A more interesting part is the strings XML. And here I am highlighting this Google API key. And I'm highlighting this because it's the strings is also, of course, recovered fully. And my first recommendation for you is that you don't put any kind of secrets here. You don't put anything that you don't want a third party to have, because as you can see, it's quite easy to take out. This is actually wasn't me that put it here. It's the Firebase SDK that puts the Google API here. I will trust Google and believe that they are aware of this kind of things, and that really with this API key you cannot do that much. Just probably subscribe to Firebase messaging topic or something like that. Because that's the thing, right? If you put an API, you really need to put an API key there. Just make sure that it's the scope, the permissions that it grants are very limited, and that it is okay with this API key leaking. because at some point it's just going to leak. Okay. So that's it about the resources. Let's go to the Smiley directory. Here is where we find the decompiled source code. So our Java and our Kotlin code is compiled to Java bytecode, and then is passes through the dexer and gets into the dex bytecode. An APK tool takes this dex bytecode and converts it to Smiley. And Smiley is the name of the language in which it's written that we are going to see in about a minute. We have the typical Java package directory structure where packages are nested in directories. And we can see, for example, that I used ProGuard when obfuscating the application because of the ABC directories that we have here. This hints us that I used ProGuard. But more interestingly, I can, from the manifest, I know that the main package of the application is called Marc Obrador Sureda Festival, and because ProGuard tends to break things when enabled, I had to leave some classes out of the minifier, and I will start looking around on this package to see what I can find. And there's a bunch of Pojo objects, but there's also a class that looks a bit more interesting, which is the REST API v1 definition.smiley. So knowing what an application is doing with the backend is always a good idea. So I will check out this class. And for example, and this is already Smiley code. This is what a method gets compiled to, or decompiled actually. And we have a get beers method, which is retrieving the beers from a backend, which is somewhat expected for a beer festival application. From here we can also see that I'm using retrofit, which is something that we learned for free out of looking at this code. And down here I see the annotation, which is, we know that is a get request, and I have the path to the backend, which is API v1 beers. So why not try to hit my my REST API and see if there's any luck. I need the base URL, so I can just search in this Smiley directory if there's any string which start with HTTPS, since all URLs start with the same. So I searched for HTTPS, and there's something that looks promising to be a base URL for the REST API endpoint. So I open up a terminal, I use wget and put the base URL followed by the path API v1 beers, and success. I just hit the REST API. Of course, this is not, you are going to tell me, Mark, this is not something critical to me. This is open information. Yes, and that's completely true. What I want you to take up from here is not what I could do, but how easy it was to actually find this information, where the REST API was defined, where was the path, where was the base URL, and if I could take this, how much could I take if I spent some more time? That's the main point. That actually reversing the Java and Kotlin code is fairly easy. So let's keep looking around, and we see that in this same class there is a get discount codes method, and that seems a bit more interesting than get beers, right? If you look into the app, we see that for these events that require signing up, there is a sign up button and a deal price, which is basically just meant for people to sign in for these events in the application, instead of stopping everyone on the street and asking them to sign up, just to bring some order. So there's a small discount if you do it through the application to encourage people to do it online. And if I try to hit the REST API this time, we see that it says authentication failed. So for API v1 beers, it's okay, but for API v1 discount codes, it says authentication failed. So let's take a closer look. Let's see what we can learn, how this authentication happened in this case. Again, back to the Smiley code, the get discount codes, we see that it takes two parameters, and these two parameters have retrofit annotations, which are which specify that these two parameters should be added to the headers of the request. And the first one actually is the authorization header. Okay, so let's take a step back and let's try to see where it is actually being set. Okay, so we search where it is used in the Smiley directory. There's only one place where this is used, and is this method here. I know there's a bit of code. I don't want you to read it all. I will guide you through it. And again, the goal is that you understand how easy it is to read Smiley code. I just want you to show you how easy it is to read Smiley code. Okay, not the content of the code that we are actually reading. So we see that the get discount code is called here. And on the left-hand side, we see that V0 and V1 are the input parameters to this code. So let's search. Remember, we were interested in the first parameter, so we need to see where V0 is set, which is here. Okay, it's we are using OKHTTP credentials basic, which gives us the information that we are actually using HTTP basic authorization header, which has the form that you can see on the right-hand side. It's a base64 encoding of username : password. So it's fair to assume that the first parameter of this method is the username, it's a username, and that the second parameter is actually a password. So let's, we see that these two parameters on the left-hand side are, again, V0 and V1. Let's see where they are set, which is here. And we see that these two parameters are set by two different methods, A and B, of the same class, which is BUP. Okay, so let's go to this class and check out these methods. And we see that these two methods are actually quite similar. They both start with a constant string, which is different in each case. They then have a second constant string, which is the same for both. And then they invoke a third method, which is in this same class, which takes these two constant strings as input parameters and returns another string. And this string is what is actually getting returned, which means that the result of this method here is going to be the username in one case and the password in the other case. So let's go take a look into this method. Again, it's kind of a bit of Smiley code. Just don't worry, I will guide you through it. Bear with me, and we'll be through it in a minute. The first thing this method does, it's taking the input strings and converting them to char arrays. Okay, and then down here we see something that should actually ring a bell. We have two position markers at the very beginning, at the very end, go to 0 and condition 0. Then we have a condition, if V1 is greater or equal than V2, go to condition 0. And at the end, we have an add 1 to V1 and go to 0. So if you think a bit about it, you are going to see that it's actually a for loop because of the comparison and the increment at the end. So what we are doing, if we see the value of V2, it's actually the array length of V0. So what we are doing here is we are iterating all the characters in the first string. And if we look inside the for loop, we see the last instruction that gives us a hint. What we are doing in this method is we are XORing the first string with the second string, which means that if we remember that we are looking for the username and password, basically the username is string 1 XOR string 2, and password is actually string 3 XOR string 2, where string 1, 2, and 3 are the ones that I showed in the previous slide. Needless to say, please, if you have a real world app, a commercial application, never do this. So you just saw how easy it is to take it out. Do not do XOR as a means of hiding stuff in your applications. As I said, I did it. That's an application that I did mostly for fun and for no profit. And the only reason for this was to try to get people to register online instead of face-to-face. that's it. If you are trying to protect something a bit, which is of a bit more value, just don't use this trick. Okay. So closing in on static analysis. Again, what I'm trying to share is not the information that I took out of my application. It's how easy it was. Okay. And the question is, what can we do about this? Well, luckily there are some things. ProGuard is a good start, definitely. It's for free. It comes with Android Studio. Sometimes it generates a bit of problem and you have to exclude classes, but there's really no reason for not using it if you don't have anything else. Of course, there are other paid alternatives. There are some companies that make out a living out of obfuscating Java code. And the idea behind obfuscation is that it's going to be more difficult to actually reverse your code. And it's going to be much more difficult trying to extract information out of a static analysis, especially. And last but not least is there's the Android NDK. I know you Android developers love Kotlin. You consider that Java is out of another age, and needless to say, C is like something you never want to see. But actually, if we write some of this stuff in C, because of the way that C is compiled, which is compiled down to assembly, someone that will try to reverse engineer our C code will need to actually reverse engineer assembly code, which is way more difficult than reversing Smalley code. So if you have some sort of secret, it's very recommendable to move it to a native layer. It's very something I would strongly recommend. Okay, so that's it about static analysis. Now, second part would be dynamic analysis. And during dynamic analysis, what we are doing is actually running the application. We run the application and we try to extract some information while it is running. So it's no longer something that is sitting on our workstation. It's something running on a device or on a simulator or an emulator, sorry. And we are trying to instrument it somehow. There are different types. The dynamic analysis covers many different topics. For example, sniffing the network communication between the application and the backend. Debugging the application is also another form of dynamic analysis to try to see the value of some variable during runtime. And another example would be try to connect an instrumentation framework like Frida or others that allow you to manipulate or to dump certain information while the application is running for you to take a look at while it is running. Today, I'm going to be focusing on network sniffing or setting up a man in the middle. It was what was easier to show, and network communication is actually something that yields a lot of information about how the application is behaving. For this, I'm going to be using Child's Proxy. That's a Mac application. It's not free this time, but they have a free demo which you can run for 30 minutes sessions. After 30 minutes, your session is going to expire, but if you just want to play around, it's probably okay. So let me show you how to set up Child's Proxy. Basically, it's, as I said, it's a proxy, as the name says. So we have to set it up and to listen to a port. I set it up in the 8888. Make sure that you enable SSL proxying. By default, Child's is going to just transparently leave the SSL traffic and not capture it. But we expect all applications to actually use HTTPS nowadays. That's like the base security. If someone is using plain HTTP, it's even easier. But let's assume we use SSL. So once we have enabled the Child's proxy, we have the Child's proxy running. The next thing we need to do is we need to fire up an Android emulator. And in the settings, there is a proxy configuration. And we enter the configuration of Child's proxy. So we enter the IP and the port where Child's is listening. And next thing is we just need to launch the application. So ADB install the APK that we just download. We start the first application that we have in mind, and we go check Child's proxy. Well, it didn't work. So on the left-hand side, you can see this unknown with the red cross, which means that Charles could not sniff this communication. If we select one of these unknown in the left-hand side, we are going to see what I have below, which says that you may need to configure your browser or application to trust Charles root certificate. So what has happened here is that because I enabled SSL proxying in Charles, because I want to see the SSL traffic, Charles is actually terminating the SSL connection and re-encrypting or establishing a different SSL connection between itself and the backend. And of course, when the client receives the certificate, it doesn't receive the certificate of the backend because Charles does not have the private key of the backend, and instead the application is receiving the Charles proxy certificate, which is an untrusted one because it's a proxy and it's a reverse engineering tool, and you should not accept this kind of certificates in your application. But luckily, Charles Proxy has a nice help menu where if we go to help SSL proxying, we see that it has to browse to chls.pro/ssl on the device and install the certificate. So that's the next thing we do. We go back to the emulator, we go to chls.pro/ssl, and we are prompted with this certificate installation pop-up. So we just put a name and we hit OK. So what we just did actually is we told the operating system, we told Android that whenever he sees this specific certificate, that he should accept the connection. We told the operating system, hey, if you see this certificate, that's okay. Just go ahead and do not terminate the connection as it was doing before. So let's give it another try. We launched the activity, the application again, and now this time it worked. So we can see that the application, when it's starting, is heading these 4 endpoints, events, peer discount codes, and we can see a lot of information here about statistics and so on. But more interestingly, if we select one of the requests, we can see on the top, we see the headers that this request sent to the backend. And on the bottom part, we see the response. Okay. That's for example, for the events, and then it's for the discount codes, the request that we saw before during a static analysis. So here in the response, I can see a value of the discount codes. I could actually take this and put into Eventbrite to get discounts. And on the top, what we can see is actually the authorization here. So actually, by doing dynamic analysis, we get the same information that we had before, or maybe even more, because there are some things that it may be a bit difficult to do during the static analysis, and during dynamic analysis, then it's a bit easier, or yeah, I would say easier to get. It's a bit easier, a bit more difficult to set up, but then the results are a bit more direct. So I could just actually take the value of the header here, put it in a wget request, and then I would be able to download the discount codes, to hit the API endpoint and download the discount codes. Again, that's not something you want to do, particularly having static API keys. Again, if they protect something which is worth it, it's really not a good idea. I would recommend and encourage you to actually use dynamic tokens like JWT tokens, which are time scoped and individual for each device. So it's a token that has like 5 minutes times lifetime, and then it's yeah, the damage that you can do with this kind of things, it's more limited. So how can we protect against dynamic analysis? Well, for static analysis, the idea was to use obfuscation and to make it difficult to read the code. This time, the idea is to make it difficult to use or run the tools that someone would use for doing dynamic analysis. What this means is that we shall try to prevent the application from running on rooted devices, on emulators. We should try to prevent the application from being debugged or from being hooked by a framework like Frida. And we do this by putting some code in the application that checks if any of these things are happening. And if that's the case, then we can, for example, crash the application. I don't have much time to go into the details on how to do this, but you can just Google it, and there are lots of information online on how this can be done. Another thing that we may want to do to protect against dynamic analysis is using certificate pinning, actually, which I'm going to be talking in the next slide. And another thing that we can do is to prevent application tampering, which is the last part of my talk. So just let me talk a bit about certificate pinning, and then we go into application tampering, and we move on. So what is certificate pinning? When we do certificate pinning, what we are doing is, remember that before I said that when I install the certificate, what I'm telling is I'm telling the operating system, hey, whenever you see this certificate, in my case, the child certificate, whenever you see this certificate, it's okay, accept the connection. And then when the application connects, it's actually relying on the operating system, it's relying on Android to decide whether the application, the connection should be accepted or not. When we do certificate pinning, is we decide that we don't want to trust the operating system because of exactly these kind of things. And we, as application developers, put the certificate of our backend inside the APK. So when the connection is established, the APK is deciding whether or not this connection should be established or not. And we don't rely on the operating system anymore. And of course, when someone installs a root certificate, a child certificate in the operating system, because the application sees the child certificate and not the actual server certificate, then the application decides that he doesn't want to proceed with the connection and will abort. Okay. This is something that is supported by default on Android. You have the link to the documentation here. It's fairly easy. It has some maintenance hiccups, so you have to be especially aware that if you change the certificate of your backend, then your applications will not have connection to your backend anymore, because that's what certificate pinning is doing. So be aware that there are some cases where you can actually deny service to your users, but it's actually a very good idea to use certificate pinning, at least to protect the user's privacy. Okay, and finally, the third part of the static analysis is trying to tamper with the application, to try to modify the application for some purpose. For example, let's imagine that my application had certificate pinning on it. If I would have run it, in this case, in Child's proxy, I would have seen that that the connection was not established. So as a reverse engineer, I may want to try to remove it because I want to see the network connection. And the same would happen, for example, for debugger detection or emulator detection, all the sorts of things that I said before, that if you want to run it in an emulator and the application has emulator detection, you may want to look around into the application and remove these checks so you can actually bypass them. So let's try to remove certificate pinning from the application. Let's go to the output of APK tool. And this time we see that there's a network security config XML file. And it looks pretty much the same as we saw before in the documentation. You have a configuration for the domain of my backend, which we already know because we've got from the static analysis part. And here we have a pin for my certificate. So all I need to do is actually remove. So I will just go ahead and remove the whole file. And then if I go to the Android manifest, I see that there's a reference to this file. So I will just remove this reference as well. And that's all I need to do to remove the certificate pinning. And the next step is I need to create a new APK, including these modifications, and install it into the device. So let's give it a try, okay? Again, I'm going to be using APK tool. This time, instead of T, I'm going to be using APK tool B for build. I can specify an output name of the APK, and the last parameter is actually the input there where I have my modified code. This is going to create this modified unsigned APK, and because the APK that it creates is unsigned, I need to use APK Signer, which is a tool that comes from bundled in the Android SDK to sign it. Since I changed the signature of the application, I will need to uninstall whatever I had installed previously, and now I can run my modified application. And I go back to the child proxy, and now I can see the network communication again. So I've removed a protection measure that the developer put in place to my advantage. Okay, what can we do? That sounds scary, right? Luckily, there's a way to actually protect against doing certificate pinning. Against application repackaging or application tampering, whatever you want to call it, which is taking advantage of the fact that any application that runs on an Android device has to be signed by the developer. So you as developers have a signing key of your application, and the certificate that corresponds to your signing key is actually bundled with the APK. So during development, you can put this certificate inside your code, and during runtime, there is an API to retrieve the certificate that was used to sign the APK that is actually running. And this should match, because when you upload your application to the App Store, you sign it with your certificate, which is the one that you put in the code. But if these don't match, it means that someone re-signed your application. And if someone re-signed your application, it's very, very likely that he actually tried to reverse engineer it and to tamper with it. Of course, the good thing is that this is pretty easy to integrate, to implement, and you have to. It's safe because it's safe as long as you have your development key stored safely in your environment and has not leaked to anyone. Okay. So that's it, right? It looks like we are done. That's by the way the amount of beer that we sold in one afternoon and one night. Sorry. So it looks like we are done, right? We know how to protect against static analysis. We can do obfuscation. We know that with the runtime checks, like with root, debugger, application tampering, as a certificate pinning, and so on, we can protect against dynamic analysis. And with the repackaging detection, we can protect against anyone detecting it. Well, unfortunately, this repackaging code can be removed too. So there is no guarantee that this code will not be found by an attacker and removed, opening the door to someone actually tampering with your application and recompiling and removing the rest of the checks that you have there. So in order to wrap everything up, let me share some closing thoughts. The first one is the sad one, is that there's a lot of information that can be taken out of an APK, and if you have everything in Java and you don't have measures in place, it's fairly easy. I'm by no means a reverse engineer expert, and it's fairly easy to extract information. So what can we do? My first or my advice is that it's very important that you know exactly what is at stake, so that you know exactly which kind of things you ship with your application, and it's normally a good exercise to do that you or someone on your team or even a pen tester, that there are companies that do this, looks into your application and gives you the information they could extract. it's very likely that you are going to be surprised by how much information could be taken out of the APK. And it's very important to know what you are actually sharing, because the protection level that you have to put needs to be in line with the value of the things that you are trying to protect. So it's not the same protecting, for example, an application like I did, which is basically an application that we did for fun, for the sake of having a better festival and a cooler festival, or a weather application. You don't need the same kind of protections that you would need if you were developing a banking application. Or like, for example, one of our customers is a car manufacturer that allow its customers to open and drive their car just by using the not drive, but turn on the engine of the car just by using a mobile application. Of course, if it's what is at stake is the possibility of stealing a car, an attacker is going to be willing to invest much more time in reversing the application. So in my case, in the case of my application, the more they are going to get is a €5 discount code, and after 5 minutes of doing this, it stops being worth it, or even after just 1 minute. But if you can take a 50K car out of reversing, how much time would you be willing to invest to actually be able to steal a car? So the value of what you have hidden inside your APK, again, is what should determine the protection level that you need to put into the application. And this is why I encourage you to actually take a look into your app, know what you are actually protecting in your application and how much worth it is, and then you can evaluate whether the protection measures that you have in place are enough or not. Yeah, no, I'm just done. So that's it. Thank you very much.
Thank you, Mark. So we can now switch to questions. We have a few questions there in the Slido.
Okay.
I can read it. So the first question is, what are the best practices to store and protect sensitive data in APK? For example, during CI/CD process, settings, secret keys, endpoint URLs. What do you think?
Mm-hmm. There are a few things to bear in mind. The first thing is to try to avoid it. Of course, it's not always possible, and you are talking about URLs and so on, and URLs by default are not a security issue on its own. But when you move to API keys and these kind of things, there are several ways. The first one is to try to not to put them, but that's not always possible. The second best practice is to try to limit their value. So it's not the same having an API key that allows the user, for example, just to log in, and from here on using a user issued token for the rest of the operations. So that's the second thing. Try to limit the amount of things that the API keys that are put into the application have. And the third thing that you can do is you can actually try to hide them. As I said during the talk, you can use obfuscation. You can use things like moving things to native, something like I did with, like I showed you with the XOR, but so using something a bit more advanced. Again, the how much you want to invest, it's going to be limited by the value that it provides. So that will be the third time. The three things. Try not to put it. If you have to put something, try to limit its scope. And if you have something that is dangerous, try to hide it either using obfuscation, moving it to C code, or trying to do some sort of encryption with more hiding layers than I showed you, and try
Thank
not to
you.
share it on the network request as far as possible.
Yeah, thank you. The next question is, are there any advantages of Smalley over decompiling to Java code?
No, actually, it's that it's not possible to decompile to Java code. It's what the tool does. It's not always 100% possible to recover the Java or the Kotlin code. It's not that it's an advantage; it's that it's what we get.
Okay, thanks. And the last question has two parts, but I think it's together. So why would not attacker simply remove any checks for like checking the resigning of the APK, or just
Mm.
change the expected signature with the signature he's resigning?
Yeah, exactly. That's what I said. These kind of things can be removed altogether by someone which is skilled enough. So if you put this kind of checks like in plain Java, like I showed you, then it's going to be very easy to remove. So that this is why it's very important that if it's really important that someone does not reverse engineer your application, that you do some proper obfuscation. If you don't want to pay, again, move it to assembly code. That try to put a few layers of misguidance. Like for example, it's not the same having the whole certificate like in plain in the code, or having it scattered in small pieces, XORed with things, or even encrypted with a key that is also scattered throughout the code. It's basically playing hide and seek. The more time you invest in hiding, the more difficult is going to be to find it. So that's all you can do. There's no silver bullet here.
Thanks. We have three new questions. So
Okay.
first one is, what protection mechanism would you use to protect 1 million euros? Or what mechanism did you use for expensive cars?
Well, there are lots of things that we do in this case. And first of all, for example, our SDK is fully written in C, so the Java layer is just for exposing it to developers. And then we use all the things that I share with you, plus some others. So for example, we have an in-house compiler that obfuscates all the C code. So it's not that just C code, it's obfuscated C code. Then we try to limit the amount of time that a key can be used. So it's not only that we try to protect the key as best as possible. It's just that, for example, the key that ships the application only allows the application to get an individual key, which means that each key in each device is different from one another. Then also these keys are only valid for a limited period of time, like for 30 days normally, and after 30 days we remove them. These keys are in BBC format, so it's something which is much more complex, and don't hide 1 million euros in an application. Just don't. There's one thing I always say: if the NSA comes in and decides that they want to hide their application, it's not a matter of if they are going to achieve it, but when they are going to achieve it. So the important thing is that we need to understand is that anything that we put into the application, someone determined enough and skilled enough is going to take it out. That's like the harmful truth.
Thanks. So three last questions. How secure are strings put as build config fields?
No, they are not secure. I mean, it's you could just take them from a Smiley. You would, if you open the build config class in Smiley code, you're just gonna see them right away.
Sure. Last two questions. Last two questions. Do you have any experience with safety net attestations API? Would you recommend it as a defense against app alteration?
Yeah. Yes, safety attestation is something quite cool. For example, for root detection, that's something that works quite well. And furthermore, Google is actually updating it behind the scenes as a part of Play services. That's quite cool. As far as I'm concerned, and I would need to double check, it does not allow against application tampering, but it allows you to detect tampering with the device. So it's not tampering with the application code itself, but it detects that you are running a custom ROM or a custom recovery or something like that, or a ROM that has not passed the CTS, the compatibility tests I said, compatibility tests with that Google enforces. So it's a good thing, but you need to know what it can be used for, which for this is basically root detection and compatibility tests with compliance.
Thanks. So unfortunately, we don't have any more time for questions. The speaker will now go to the 3D world, and you can ask him more questions there. You can find Speaker's Corner in the 3D world next to registration for this stage. And when you are in 3D World, visit our partners booth. There are some surprises for you, both virtual and real. And now I will enable rating for this talk. So in Slido, please vote for this talk so the speaker can have some feedback. We will meet again for the last presentation in this room at 16:15. That's 4:15 p.m. And I would like to thank Marc a lot. Thank you.
Thank you guys, and see you in the speaker's corner.
Yeah. Bye bye.